Welcome to the module on basics of concrete. Today we will be discussing about the water curing, how the water curing is effective, what are the different types of water curing generally observed in the construction industry, and so on. Let us define what is curing. What is meant by curing? Curing is the process of controlling the rate and extent of moisture loss from the concrete during the cement hydration. That means it is stated clearly that when the cement hydration starts, then the loss of moisture from the surface of the concrete also initiates it. So, in order to restrict or prevent this moisture loss or control the loss of moisture from the surface of the concrete, curing is required. Different methods of water curing, if you see, one is replenish water by immersion, which is generally used in the laboratories where you immerse the cube molds in the concreting tank. Second is replenish water by ponding. That means you need to prepare a pond type structure on top of the surface, mainly used in slabs where you do the ponding arrangement by making small bunds either with the clay or with the mortar materials, and then apply water on top of it, so that a layer of water is always there on top of the surface of the concrete. The third is replenish water by sprinkling, and the fourth one is application of a wet Hessian clothes on top of the concrete. That means the concrete is completely covered with the wet Hessian clothes. Hessian cloth which is being wet with water. So the idea is at any point of time, under any circumstances, the concrete surface which is directly exposed to atmosphere needs to be covered, so that that cover will act as a barrier between the loss of moisture from the surface of the concrete. So this is the example of replenishing water by immersion, which is generally you can observe it in a laboratory at any construction site or even in the colleges, where the concrete cubes which are being cast before testing were allowed to cure for 1 day or 3 days or 7 days or 28 days, depending upon the age required to test those samples. Now, there are two things which is important in this particular model is you need to change the water very frequently, so that your water will not get polluted because of the bacteria or other materials which are harmful for the concrete. And second is you need to maintain the temperature of the water which is there inside the curing tank. The temperature of the water generally required to be maintained is 27 plus minus 2, which we have seen in our previous module also when we talked about the importance of curing in concrete elements. So the idea is if you are able to maintain a temperature of 27 plus minus 2, then probably the early strength, that is the 1 day strength, and the 28-day strength will be at par. Otherwise, you will have a large variation as far as the 1 day strength and the 28-day strength is concerned. Second is, then the third important thing is the curing tank which is being made in the project or at any testing laboratories needs to be covered under the roof, so that direct sunlight will not have an impact on the temperature of the water. So this is what is the requirement as far as replenishing water by immersion methodology is concerned, and generally used in a testing laboratories to cure the cubes. And sometimes the immersion methodology is also used for a precast unit, like for example the manufacturing of the spun pipes, where the complete pipes are being immersed in a curing tank for 7 days or 14 days depending upon the requirement. So at that particular point also, that curing tank also one needs to be covered. Otherwise what will happen is in summer when the ambient temperature goes around 45, then your water temperature also is crossing the limits specified by the standards, that is 27 plus minus 2, and you will have a higher temperature. So with the higher temperature, even if you are not testing the 1 day strength, when you are going to test the 28-day strength, your 28-day strength will be less than the average strength you normally get when cured at a temperature of 27 plus minus 2. So it is important to make sure that the curing water temperature in the curing tank should be maintained at 27 plus minus 2 at all point of time, because this is the result which is indicative in order to accept or reject a material. So if higher temperature gives less strength at 28 days strength, then that means you are having an issue as far as the concrete mixes is concerned, and probably without checking the temperature of water, you try doing modifications in your mix designs, which is not at all necessary, because the change in strength is mostly because of the temperature of the water, which is not being maintained at 27 plus minus 2 degrees centigrade. Similarly, the size of the curing tank also, we talked about the size of the curing tank which one has to maintain. You can click on the link in order to see how, or in order to see the Excel sheets, or in order to see the previous videos, which I will be again sharing it in my description box also, that how to estimate the size of the curing tank in a project depending upon the concrete quantity you are planning to pour. For example, if it is 300 cubic meters per day, then the size of the tank will be different. If it is 500 cubic meters per day, then the size of the tank possibly will be different, because the number of cubes to be cast as per IS 456, the sampling size which is given in IS 456 is for testing at 28 days strength, and other than those samples, again you need to cast additional samples if you want to check your strength of cubes for 1 day, 3 days and 7 days. So the number of cubes will be higher depending upon the quantity of the concrete which is being poured. So a detailed calculation is explained in the module which is related to the estimation of the size of the curing tank. If you have not gone through that, I recommend that you must see that module also in order to get a clarity what should be the size of the curing tank in your project sites. But as far as the storage condition is concerned, this is the bandwidth of 7 days storage, indicating that the cubes are being tested at 7 days, because at any point of time this will be the occupancy of the cubes as far as the 7 days strength is concerned, and the below tank will be the 28 days strength is concerned. So the area covered by 28 days strength and the area covered by the 7 days strength will vary depending upon the quantity of the concrete which is being poured in the project per day. Now coming to the second method, that is replenishing water by ponding. This is generally used for a base slab or the roof slabs, where you can make a temporary bund and then pour water so that you can have a layer of water on top of the concrete. This is suitable mainly for the horizontal surfaces where you will be in a position to keep the water at that position. If it is in the sloping conditions like vertical walls and all those things, here the ponding is not possible because your water will not stay in that particular position. So mainly this method is applicable only in the horizontal cross sections, and again the temperature of the water is also important in this particular case also. So generally in the summer season you need to change the water frequently, you need to recharge the water frequently so that the temperature of the water should be maintained 27 plus minus 2. Otherwise, the strength of the concrete which is there actually in the field will be reduced considerably because of the higher temperature of water. So if you are not able to maintain the temperature of the water, then better to change the type of curing. Rather than going for a ponding method, you can go for a curing by membrane or curing by any other method which is easy and where the requirement of temperature is not given. So in my opinion, if you are not able to maintain the temperature of the water, then better to switch to the curing compound, which is the best solution at any point of time. Similarly, replenishing water by sprinkling, wherever the water comes into picture, the temperature of the water is important. So whether it is sprinkling or ponding or immersion, at all positions, your temperature of water is more important when you are doing curing with water. So if you are able to maintain the temperature of the water, you can continue curing with water. If you are not able to maintain the temperature of the water, better change your curing methodology to some other methods where the restriction of temperature is not required, and then you can have your conventional method of curing. So this is the basic sprinkling on vertical faces, but generally in the vertical faces you can have a wet Hessian clothes and then cover, then sprinkle the water on top of the wet Hessian clothes, so that the loss of water from the Hessian cloth will also be reduced, and you will have some cover as far as the loss of moisture is concerned. If you apply directly on the concrete surface, the water will not stick to it, and you will drain out all the water which is being sprinkled within no time, especially when the ambient temperature is very high. Or the second method is you can have a network of small pipes, mainly a PVC pipe of say 1 inch dia or half inch dia, with perforated holes in between, so that after completing the concrete, because it is a precast unit, you can always run that sprinkler continuously throughout the time, and you can have a drainage arrangement so that whatever is being drained out is being collected back into the pond, and then the same water is being pumped and is flown through the pipes. So this is how the sprinkling arrangements can be done. Then coming to the application of wet Hessian clothes, the idea is to cover the entire surface with the Hessian clothes and then apply water through sprinkling or ponding, so that the Hessian cloth which is being spread across is completely wet, and the loss of moisture can be minimized, because this condition can be retained even if the atmospheric temperature is high. These conditions can be retained for a longer duration of time rather than sprinkling the water directly on top of the concrete. But in cold weather conditions, when the ambient temperature goes below say 5 degrees or 3 degrees, then the water temperature also drops to the same ambient temperature. So especially in the cold climatic conditions, when you need to run your curing tank, especially in the laboratories where because of the production of concrete, you are always generating the cubes, and you need to test those cubes for 7 days and 28 days. And if the curing tank water temperature is say not 27 plus minus 2, but it is dropped to 5 degrees and 3 degrees and 10 degrees, then possibly your initial strength will also indicate very low, and which will be misleading, and you will be always in a worry whether your 28 days strength will pass or not, or the later days strength will pass or not. So it's always required to maintain the temperature of water when it is in the cold climatic conditions. You can always circulate a hot water continuously inside the curing tank, and you can connect these things with a thermostat, so that the moment you achieve the required temperature, the flow of water, the flow of hot water stops automatically, and then at any point of time your tubes which are there in the curing tank will be in a position to maintain the 27 plus minus 2 degrees centigrade for curing purpose. Now, the biggest question is, can we use seawater for curing? People say yes and people say no also. But if you see the graph which is being reflected over here, there are tubes which are being tested for 7 days, 14 days, 28 days and 90 days, and under 3 conditions, like curing with fresh water, curing with seawater, and curing with seawater when the cement is also changed, that is, instead of OPC we have used the SRC cement. Now if you see the results, fresh water curing, which is being shown by a blue line, is always with a consistent growth pattern, like 1 day strength is more, 1 day strength, 7 day strength, then 14 day strength is more than 7 day strength, 28 day strength is further more, and then the 90 day strength is also in the increasing order. But when you see the curing with seawater for the same mix, you may have the early strength, initial early strength for 7 days, but when it comes to 28 days, 14 days and 28 days and 90 days, you can see a consistent appreciable drop in strength as compared to the blue line, that is curing with the fresh water. But in case if you change the cement from OPC to SRC, then you can see that there is a quite big jump in the initial strength of 7 days. There is also a jump in the 14 days, also in the jump in the 28 days strength. But when it comes to 90 days, it is equal to the samples being cured by fresh water made with OPC cement. So if it is required to go for a seawater curing only, then better to adopt SRC cement rather than going for a OPC cement, because by choosing the OPC cement, your compressive strength drops drastically starting from the 14 days, 28 days and 90 days. But when you look at the other strength, like the tensile strength, flexural strength and the bond strength, when you cure the concrete with seawater, your tensile strength reduces by 30%, your tensile strength reduces by 25% for SRC type cement and 30% for OPC type cement. Your flexural strength is reduced by 50% for OPC cement, and the same is reduced by 40% when you are using SRC type cement, and the bond strength is reduced for both the cases by 30%, whether it is OPC or SRC, when compared with the results of the 90 days being cured for fresh water and OPC concrete. So that means if you are using SRC cement, you might be able to achieve the compressive strength at par on 28 days strength and 90 days strength, 90 days, not 28 days, it is 90 days. But the other strength, which is tensile, flexural and bond strength, are not going to be the same even if it is 90 days. So they will be reduced by almost 30 to 50% at any point of time, whether it is SRC or it is your OPC cement. So considering these two aspects, if you are bothered only about compressive strength, possibly you can use seawater. But if there is a requirement for tensile, flexural and bond strength also, then possibly you will have difficulty in using the seawater for curing. So it is advisable to use clean water fit for drinking purpose to cure the concrete. However, it is observed that with SRC cement, the compressive strength is achieved equal to the OPC cement when cured with seawater, but the tensile strength is reduced by 30%, flexural is reduced by 50%, and bond strength is being reduced by 30%. So if at all seawater is required to be used, then concrete must be re-looked at, must be redesigned to compensate the reduction in the strength of tensile, flexural and bond strength by changing the water cement ratio or the other measures, which is basically happening because of the presence of the salt in the water. So the if you see the effect of chlorides and sulphates present in the seawater, the chlorides tend to accelerate the setting time of cement, and they try to improve the strength of the concrete in the early stages when it is being mixed in concrete. On the other hand, the sulphates tend to retard the setting time of the cement and discourage the strength of the concrete in the early stages. Therefore, the net effect of these two components, that is the chlorides and the sulphates, if you see, the net result is there is a fall in strength to the tune of 20% in the concrete. Therefore, seawater can be used for making cement for structures where such fall in strength is permissible, or where it is possible to correct the same by adjusting your water cement ratio, adjusting your cement content in concrete, and the other respective parameters like type of aggregates and such grading of aggregates and presence of fines, presence of silt and clay in the fine aggregates, and so on. The other problems which are associated with seawater is because of the seawater, they tend to develop the dampness as well as the efflorescence in the concrete. So if you prepare the concrete with the seawater and cure it with the seawater, then probably your concrete will show the dampness, also the efflorescence effect. Hence, it can be adopted for structures where finishing characteristics are not that important, or where the persistence dampness of the structure is permissible and it is not going to bother you much from the defect point of view. So under these conditions, probably we can think of using the seawater for making of concrete or curing of concrete. But ideally, if it is SRC and your compressive strength is the only criteria for making of concrete or approving of concrete from the durability point of view, then probably with SRC you can go for curing of concrete with the seawater. But when flexural plays a major role in the designing of the elements of the structure made of concrete, then probably you should not go for the curing of concrete with the seawater, because flexural strengths are being reduced drastically to the tune of say 40 to 50% when seawater is being used to cure the concrete. But if you are able to compensate the reduction in the strength by improving your design mixes, by improving your grade of concrete, by improving your cement content, then probably with that cost you need to again compare the cost of the modified mixed design and the cost of getting the potable water for curing of concrete. If they are at par, then probably you can modify your mixed design and use it for the concreting to be cured by seawater. So to summarize this module, we talked about the definition of concrete curing, we talked about the water curing, the different types of water curing, what is immersion, what is ponding, what is sprinkling, what should be the temperature of the water for curing, and how it is important under the cold and the hot climatic conditions, especially for the structures which are there in the field, because the temperatures can be maintained in the laboratory, but in the field it is not going to be easy to maintain the temperature of water. So under that conditions, what should be the alternate methods available in order to make sure that the concrete is being cured, it will be discussed in the upcoming modules. And then the different types of conditions for curing of concrete is being discussed in this particular module. The suitability of seawater, the most important part, the suitability of seawater for curing of concrete elements. As we have seen that the seawater has an impact on the compressive strength, the tensile strength, the flexural strength, and the bond strength of the concrete. By using the seawater, these strengths are being reduced appreciably to the tune of 20 to 50%. So in the next upcoming module, we will be talking about the membrane curing, where of course the temperature criteria won't be there like we consider in water curing, where because in water curing you need to maintain the temperature of the water 27 plus minus 2 degrees, whereas in membrane curing such requirements won't be there. But of course there are some other limitations of membrane curing which we will be discussing in detail in the next module. Till then, thank you very much. Tune in for more updates.